welcome to the episode of Rustacean Station. I'm your host, Alan Wyma. Today I'm with, I forgot to even pronounce your name. Do you mind to pronounce your name for the audience?
Yeah, my name's Mrinal Wadhwa.
Yes, Mrinal, who is the CTO over at Ockam, whose product is also called Ockam, as you just explained to me. Welcome.
Thank you. Thank you for having me, Alan.
So as we were talking before the show, originally I heard about Ockam from, I think it was Thinking Elixir podcast about a year or two ago. It's always been on my radar. I kind of understood what it is, but at the same time didn't. What I understand is, maybe I'll let you introduce the product, but the cool thing is that you're using two technologies that I really love, which is Elixir and Rust. And it's good to hear that you're also call ourselves beamers, or what kind of heavy beam users, I guess we could say.
Erlang person, yeah.
Why don't you talk a little bit about Ockam for us?
Sure. So Ockham is a collection of open source tools to make it easy for distributed applications to exchange data in a trustful way. So allow applications to be able to reason about integrity of data that they're receiving, the authenticity of data they're receiving, and have control over confidentiality and privacy of the data that is being exchanged within a distributed application. Yeah, we have an open source project. We then also offer cloud services that make using that open source tool set easier and to scale it.
Yeah, what I thought was really interesting, I remember on the previous podcast, you were talking about the example you're giving was something about like government services going over to IoT. And I think, are they actually one of your clients where it's like you want to like start protecting how like their services talk to each other? I'm trying to remember, it's been a while.
Yeah, that resonates with me. So essentially that ties back to where I came from. So before I joined this team at Ockam with my co-founder, Matt Gregory, I was CTO at a IoT company. And they hired me 8-9 years ago now to essentially take a suite of hardware products and turn them into connected products to do sense and control of city infrastructure. So we were doing applications like, control the street lights of an entire city to optimize them for energy usage. Because turns out one of the biggest expenses of a city is their energy bill for streetlights. We were doing things like flood monitoring in a city to have early warning signals of either the sewer system or the storm drain system about to be flooded in a certain section of the city. We were doing various kind of sort of emergency response type applications, etc. So in that system, we had a lot of connected devices, typically tens or hundreds of thousands of connected things, communicating with each other and to cloud services in the cloud. And when we were designing that system, I became very aware of the challenges of authenticating these devices with cloud services, authenticating cloud services with these devices to do firmware updates or software updates, authorizing actions when you have so many different things talking to each other, making sure the data cannot be leaked to people who shouldn't see that data, and the data cannot be tampered by people who shouldn't be able to tamper that data, or systems or attackers who shouldn't be able to tamper the data. So that sort of collection of challenges we had to solve while designing that system. This involved a lot of kind of protocol design and cryptography. And slowly I learned that at the time, like in 2013, 2014, when we were designing that system, there are people we could go look at. There weren't other large IoT deployments that we could use as a reference. So we ended up building a lot of this from scratch. But as time passed, I noticed a couple of things. One was I met other people who were solving the same problem in their own ad hoc, purpose-built way for their own system. I met some people at Square who were also deploying a large fleet of devices, and they told me very similar solution existed in their stack. I met some people who were deploying a large number of distributed cloud services that talked across data centers and edge data centers, and they described a very similar set of things they had to build. So I quickly had a realization that this should be a general toolkit for people building various types of distributed systems. And that's what led to what we're doing at Ockam.
Okay. Like, did you basically take all the code you made before and just kind of modify it a bit, and then that's what's now, or did you start all from scratch? Or because you said you were doing something similar before, right? And you're talking to everybody else, and they're also doing similar things. So, how much is stuff that you used before, and how much is kind of built from the ground up?
It is completely built from the ground up because I left that earlier company, which has a proprietary system. I gained a bunch of sort of knowledge and learnings from it. And essentially, this was my chance to like take all of that learning and context, do some work with people I had met along the way to understand their problems and how those problems were different to what I was dealing with in that previous systems design, but at the same time similar. So we did a bunch of sort of discovery of product needs, etc. And then we started building Ockam. And one conscious choice we made is that we'll build Ockam in the open source world. So all our code base is currently open source. The idea is that, especially in this like very security centric space, it's better to build a product as an open source product. It also has a lot of benefit in terms of like gathering feedback, getting scrutiny, all those sort of open source benefits add up. And then, of course, once you have an open source product, all the benefits of being an open source product in terms of like community engagement, etc., also then are helpful. So Ockham's built from scratch, completely open source.
Okay. I mean, there's quite a few things I want to talk about with there. I mean, for one thing, you said things are similar but different, right? How much different can things be? I mean, I understand like you want to make this thing like accessible, and I don't know, I'm just trying to understand like how different can what you have now compared to like what somebody else would actually need. Is it so much that they could build on top of what you have, or is it that really the ideas are similar but they're like incompatible? Does that question make sense?
That's a great question. Essentially, what's different across applications is usually the communication topology, but the requirements of distributed applications when it comes to trusting data in motion are very similar. They usually, the two sides that are talking to each other within an application need to authenticate each other. They need a guarantee that the data that they are exchanging wasn't tampered with en route and has data integrity. They might need a guarantee that that data wasn't revealed to anyone en route when it was being transferred. And they need to make authorization decisions about, hey, this entity in my applications is allowed to do these actions, whereas this other entity in my application is allowed to do these other actions, right? So they need control over data integrity, data authenticity, privacy of data, etc. So these use cases are always very similar, but the communication topology tends to be different. So, for example, in my previous job at Fiverr, we had a communication topology where the first hop that the message took was from a low-powered device to a gateway, like a LoRaWAN gateway. And then from the LoRaWAN gateway, it took a TCP connection back to our cloud servers. And sometimes there were intermediary cloud services involved. Like, for instance, I've seen people landing their IoT data into systems like Kafka. And then from Kafka, the data goes to some backend service, right? So this topology in our case looked like that. Whereas in a different application, the topology might be there's a service running in one private data center, and there's a different service running in another private data center or a private VPC. And these two things need to talk to each other, but they want to do so in a way that neither of them are exposing ports on the internet. And so with Ockam, it's possible to have communication between these two completely private services through a private relay in the cloud inside Ockam Orchestrator, and have these two things talk to each other over end-to-end encrypted, mutually authenticated, mutually authorized channels without revealing any data to any intermediary, whether it's Ockam or some other intermediate service like Confluent Cloud. So to answer your question, usually what happens is the use cases are the same. The requirements from the system that's providing trust in the data is the same, but the communication topologies are different. And inside Ockam, we've designed a way or like a collection of protocols that decouple guarantees you want from secure channels like data integrity, authenticity, authorization, etc., from the underlying transport layer communication protocols. So to contrast, let's take something like TLS, right? TLS provides security guarantees that are as long as the underlying TCP connection. So if a application and a cloud service are speaking using a TCP connection, you can put TLS and get all these guarantees that I talked about. But you can only have one underlying hop of a TCP connection in that scenario. But with Ockam, it's possible to have any number of underlying TCP layer hops or any number of underlying multiple transport protocol hops. So you can have Bluetooth hop, then a TCP hop, then a UDP hop, but still have end-to-end data integrity and authenticity guarantees, which isn't possible with traditional secure channel protocols like TLS, etc.
That sounds good, but sometimes things that sound good are, how you say that, dreams or whatever. But of course, it's not a dream, right? It works. Can you explain to me, like I'm 5, like how does this work? Because it's so hard to imagine. Like one of the questions we got for the person who introduced us to have us chat, he's really interested to know, how can I guarantee that, point A and point B, when they talk to each other, like you said, no matter how many hops or methods that they use to talk to each other, how can I guarantee that they are who they say they are and validate all these things? How does that work when you're going through all these different kinds of hops and could be brokers and everything else in between?
Yeah, great question. So it's a collection of composable protocols and then a collection of library functions that provide access to those composable protocols. So the way we thought about, because I was talking to a lot of people with similar use cases but different topologies, as we were designing Ockam, we were thinking about how to make this work in all of these topologies in a way that anyone can kind of compose these guarantees together, but not have to build everything from scratch. So to do that, we came up with a collection of protocols. So the very first protocol that is involved is called application layer routing. And essentially what that does is, let's say I want to send you a message, but I am sitting in my home, you're sitting in your home or in a hotel room currently, and we want to talk to each other. So neither of us are servers on the internet, which means neither of us are reachable over the internet, right? But if we put a server on the internet that can relay messages between us, and you go, hey, if someone wants to send me a message, here's a connection I'll make to you, send that message down this connection, right? So you make outgoing TCP connection to this server. I also make an outgoing TCP connection to the same server. And I then go, hey, this is Alan's address. Could you pass this message along to him? And so the server then becomes like a relay or a router in the cloud. So that was kind of the first thing we did. So we have this routing protocol that can do application layer routing, but this doesn't have to be 2-hop, right? So I could have 3 servers between the path between you and me, and it will still carry that message through. But it's important to note that this isn't network layer routing, it's application layer 7 routing, right? It's at the application layer, we have a little component that takes data from one transport layer connection from this end and sends it down to another transport layer connection on the other end. And transport protocols are plugins to this routing protocol. So that was kind of our first piece that we built. And then we used a secure channel design, which is very popular in the cryptography communities these days, called the noise protocol framework. It came from the team that's behind the Signal phone application that allows end-to-end encryption between your phone and my phone. They took their learnings from Signal's design and kind of generalized it into a general purpose framework called the noise protocol framework. This is the same framework that's used in other systems like WireGuard, and I think it's also used in WhatsApp and a few other systems. It's a very proven secure channel design. And so what we did is we took that secure channel design and we implemented it on top of Ockam routing. So to contrast this back to what I said with TLS earlier, TLS is a secure channel design that is implemented on top of TCP, whereas Ockam secure channels are a secure channel design that are implemented on top of Ockam routing. And so what happens is that because Ockam secure channels sit on top of Ockam routing, we can have any number of underlying Ockam routing hops in any underlying transport layer protocol, but the secure channel guarantees are end-to-end. So when you and I are talking through that intermediary server in the cloud, The intermediary server is relaying messages from me to you, but the secure channel is between me and you end to end. It has end-to-end encryption. It has end-to-end data integrity guarantees. So that was kind of the second piece we had to build. The third piece that needs to sit on top of this is some kind of identity/authority system. So, which ties back to the question you ask is like, how do I know you are who you are? Right? So someone introduced me to Alan over an email and said, Alan is the host of this podcast and you should talk and meet with each other, right? So in our relationship, that person is the kind of the basis of our interaction. And I'm assuming you're Alan, the host of Rustacean Station, because of that person's message and because of I looked at the website and your name was there, etc. Right? So I learned certain attributes about you that I now believe as true, and hence we're having this conversation, right? Similarly, you learned certain attributes about me, which you now believe are true, and which is why we're having this conversation, believing we have trust that this podcast will get published, right? So similarly, when two parties are talking over a secure channel, they need some basis of trusting each other. And that basis of trusting each other can be you and I exchanged our identities over a Slack channel. So we had some side channel to exchange our identities, and I know your identity beforehand, and you know my identity beforehand. Or it can be based on an authority that issues me a credential and issues you a credential. And as long as two parties talking to each other present to each other a credential stating their attributes as attested to by a authority that both of them trust, they can establish a trustful relationship. And so inside Ockam is this toolkit to manage identities, manage keys of identities, rotate those keys, revoke those keys, store those keys in safe places like hardware modules or KMS systems in clouds. And then finally, on top of this identity layer, identity and credentials layer is a attribute-based access control policy engine. And what that does is allows a company that might be running thousands or hundreds of thousands of connected things, whether they are cloud services or edge services talking to each other or tiny devices talking to other tiny devices. When someone's managing this fleet of things that need to talk to each other and trust each other, they want to manage the authorization rules in that system in a central way. And so our attribute-based access control layer provides a way to enforce these attribute-based rules in large fleets. And that's also a functionality that's kind of baked into the Ockam Rust crates and services.
Why don't we talk a little bit more about like some of the technology stack? I think it's the most interesting part, right? So obviously you're using some Rust, and that's used for cryptography, or is there anything else that Rust is being used for?
Yeah, it's used for multiple components. So the reason we chose Rust is actually we started with C. We started with C about 3 years ago and spent about a year trying to build what we were trying to build in C and face certain challenges. The first one was doing abstractions and pluggable things in C turned out to be really hard, given that we wanted to keep the interface to end users simple. So a lot of what's going on inside Ockam is protocols, right? It's asynchronous protocols that are sending messages to each other. And so to do this, we needed a way to run these protocols without the end user of the library having to like deal with the state of the protocol and write the steps of the protocol in exactly the right way, right? So if I want to establish a secure channel with you, I should be able to say, create secure channel with Alan. That should be the end of it. I shouldn't have to go, start handshake phase 1, then start handshake phase 2, and then manage the state, all of that, right? So as we started with C, we realized it was really hard to do these protocols in a good, easy, user-friendly way. Secondly, as I discovered or started learning about Rust, what I realized is that Rust has these other really nice properties that were very nice for the problem we were trying to solve. The first one was it eliminates a whole class of bugs, right, with memory safety. And by eliminating that class of bugs, it makes all our cryptography code a lot safer. It reduces the vulnerability surface of our code and the code we're writing. And writing good cryptography code is hard as is. And so why wouldn't we take on that 60, 70% reduction in bugs or reduction in vulnerability surface? So that was kind of one reason to look at Rust. But then as I dug further, I learned about async await. And that was also a really big reason why we chose Rust, is because, like I referred to earlier, we have all of these asynchronous protocols going on in our system. And to abstract them, we realized we needed to essentially have like an actor model abstraction. We needed actors in our system that could asynchronously run this protocol, and the interface to them could be simple. And with async await in Rust, it's really easy to build a actor system. So we've built a actor system inside the Ockam library that's called Ockam Workers, and that significantly simplifies our user-facing interface and allows us to go in a single line, establish secure channel with Alan given Alan's public key or given Alan's public identity, right? It literally has become one line. So that was a huge win. Another win we got with async await is our actor layer is sitting on top of async await. And because async await can work in standard and no standard environments, we can run Ockam inside standard and no standard environments. So because of that decoupling from the underlying concurrency primitives that comes with async await, all you have to do to run Ockam in standard versus no standard is replace the executor. So in standard environments, our executor is Tokyo. In no standard environments, we've written a custom executor that allows us to run Ockam in tiny chips and get all the same guarantees. So that was another reason to pick Rust. So all of this kind of put together between, good, easy abstractions, being able to rely on async await to get decoupling from underlying concurrency primitives, and also the memory safety guarantees of Rust is why we chose Rust. And what's implemented in Rust inside Ockam is these cryptographic protocols, the actor model, our plugin to various hardware components, and our command line, which we're getting ready to launch over the next few weeks. These components are all built in Rust.
Now, which pieces are written in Elixir? Because that's also interesting too. Which are those? I mean, I would figure that that'd actually be at the protocol layer because supposedly, Erlang is very good about binary manipulation and pattern matching, right?
Yeah. It's interesting you brought that up. Erlang's really good at binary manipulation, and I think the bit syntax in Erlang Elixir is just amazing, and I haven't seen an equivalent of that in any other language, even including Rust. There are certain binary protocol parsing pieces of code we've written in Elixir and Rust, and the Elixir code ends up being 50 lines to do the whole protocol, and the Rust code ends up being hundreds of lines, right? So there's this clear benefit on the Elixir side around binary parsing. However, the primary reason we chose Elixir was for the Beam and OTP's maturity around scaling messaging systems. So in the past, I've been working with Erlang and Beam for, 15, 16 years. And I have personally had great success scaling systems in Beam that are moving lots of messages around all the time, like high volumes of messages at high throughput, low latency, with a very high degree of fault tolerance. Erlang's really, really good at it. This is why you see several chat-like applications built in Erlang, WhatsApp being built in Erlang is because of that. Discord being built in Erlang is because of that. Erlang's really good at, or Beam, the runtime, is really good at giving you, with very little effort, a very scalable, robust, fault-tolerant messaging system. And so for our cloud services, we wanted that benefit of having something more mature and stable. And that was primary reason why we chose Elixir to do a lot of the work we're deploying in Ockam Orchestrator, which is our cloud service. But at the same time, we didn't want to implement all the cryptography again in Elixir. So we wanted to write the cryptography once and then use it from Elixir and have the safety guarantees of Rust. So we call Rust from Elixir using NIFs, which is the native interface functions in Elixir, Erlang. And so essentially a primary reason to use Elixir and Erlang is to have a robust, scalable, fault-tolerant messaging backend for our cloud services.
But implementing something like that in Rust should also be possible too, right? Is it that you just want to rely on like the history of Erlang and the Beam, or because I mean you could do the same thing in Rust, right?
Not only can you do it, we did parts of it, right? So as I said earlier, we went and built an actor system in Rust. So our Rust implementation includes an actor model. And very quickly, once you have Ockam workers, which are our actors, it starts to look very, very similar to the primitives you have in Erlang and Elixir. However, having an actor implementation and taking that to the maturity level of OTP and Erlang is a whole journey. And we wanted the maturity and reliability of Elixir for our backend. But for, client-side things and distributed things, we feel like what we've put together in Rust is good, and it's very quickly maturing into becoming very stable as well.
Now, when people find out that you're using Elixir and Rust, do they say good things or bad things? Because I've heard quite a few people tell me when I recommend that they should use Elixir or even Rust, they say, oh, it's such a new language, it's a big gamble and a bad idea to do. This is what I hear, right? But maybe it's because Elixir itself is a newer language, and also it's not as common as, say, Java or C.
Yeah. I'm a big believer in use the best tool for the job. And so we chose the best tools for our job, which I think if you're building a messaging system, Elixir and Beam are the best tool. If you're building a collection of cryptography-related protocols that need to run in lots of different environments, from big servers to tiny computers, without the additional cost of having a virtual machine, Rust is the best tool. And so we chose the best tools for the job. And surprisingly, I haven't come across too many critics of these choices once they listen to why we chose them. Now, we routinely come across people who want to use Ockham's tools in other languages. And our strategy for that is we will write wrappers around our Rust code in other languages. For example, we've already started work on a TypeScript wrapper, and we'll slowly do other languages. And that, I think, is another reason to choose Rust. Because Rust has the same sort of calling convention like C, it can be wrapped into any language that has C native FFI, and that's mostly all languages. And so that's also another reason why writing our code in our cryptography and protocol code in Rust made a ton of sense.
Again, I think you already know that I'm a big fan of those two languages, Elixir and Rust. But actually, the one issue I have with them is that they do take some time to ramp up on, right? Especially Elixir. It's like totally different. I mean, immutable data. I mean, Rust has that, but adding the mute keyword he'll let you change it. But it does have a lot of rules with the borrow checker. Everybody becomes a fighter of the borrow checker until they get defeated within the first 5 seconds of using Rust, right? I mean, has this ever been a concern for you guys? Because, like I said, those things are concerns that I have for every time I bring it up to a new project or team.
Yeah, I think these are all trade-offs, right? So the trade-off you make as a person kind of picking a new language for a new project is between how quickly can I bring people in with that expertise versus what is the best tool for this problem. And we leaned towards what is the best tool for the problem, but at the same time, we could see the trajectory of both the languages, right? I think both the Rust community and the Elixir community are growing really, really rapidly. Kudos to the fantastic communities in both these languages and the community ecosystem. So yes, we've had some challenges kind of ramping people into the project and like fruiting, etc. But at the same time, I'm really optimistic that there's like a really good growing community around both these languages. And so those challenges will be easier to deal with as time passes.
Now, what do you think has been the most difficult part of working on Ockam?
Well, the most difficult part is it's easy to design a specific solution to a specific problem, but we wanted to design a somewhat general solution to a class of problems. And it took us a lot of time to come up with that design while being true to our name, which is Ockam, as in simple, and keeping, like making it a one-line call to establish a end-to-end encrypted, mutually authenticated, mutually authorized communication channel between two things in any kind of topology. Coming up with the right abstractions for that was really challenging while keeping things simple. That's my answer. It's like that was the most challenging part.
Ockam itself, right, is solving a very particular problem. Is there any competing technologies or products out there right now that you guys are working or competing with, I guess I could say?
Not really. I think the main thing is we have, just like I designed a set of solutions in my previous company to this set of problems, I've now, over the years, come across multiple companies that have internally kind of purpose-built solutions for this problem. Like I spoke with one of the major cloud vendors and learned that they have a application layer security protocol internally inside the engine of the cloud platform itself. I spoke with a large consumer electronics company, and they told me to make sure that all their devices like TVs and refrigerators, etc., that are talking to their backend services, in order to make sure that they are authentic devices, they had to deal with the problem of distributing keys, establishing secure channels, distributing credentials, managing revocation or rotation of these credentials. And so they have built an ad hoc solution. So essentially what's going on in this space is people are building ad hoc solutions that work in one setting, but don't work in another setting. And the drawback of that is, one, they have to spend a lot of time and money building that solution. And two, that solution can't get the same amount of sort of scrutiny and auditing, et cetera, that we can as an open source project. Another example of that is like in the Kubernetes community, as the number of microservices are growing, people are building specific mutual authentication solutions for microservices in one Kubernetes cluster. But that solution breaks down if some of those microservices are in a different data center or in a different cluster. And now you have to come up with another ad hoc solution layered on top of your Kubernetes solution. Or if some of your services are moving to an edge data center, you now have to come up with a different solution. So I guess my answer to what's the competing thing? It's really people kind of not knowing that there's now a general toolkit and trying to come up with these ad hoc solutions in their own way, which, if you've ever dealt with cryptography and key management and messaging systems type things, takes a lot of time and energy. It's very hard to get right.
Now, when would Ockam not be a good solution compared to, say, building your own?
Well, if you're building a very simple single hop web application, then at that point, the web ecosystem has a very mature trust infrastructure, right? We have TLS to establish secure connections. We have the web PKI to distribute trust between web identities, and browsers trust a bunch of certificates in the web PKI, et cetera. So if you have a very, very simple single hop, make a web request, get a response type of use case, Ockham's not the right solution. However, a lot of modern web applications look that way, but aren't. Because actually what happens is you make a request to a load balancer, the load balancer terminates your TLS connection, and then takes the rest of the request and sends it back to some backend microservice. Now, at that point, what you've done is you've gone from a simple secure channel into trusting a big backend boundary. And now, if you want to embrace modern security principles of least privileged design, not trusting network boundaries and having zero trust application layer security, or having shift left in your security design, all of these are buzzwords in this application security space. But if you want to have that approach, which is the right approach, you can't trust your entire backend to be trustworthy when it comes to sending requests to your microservice. So terminating your connections at the load balancer is the opposite of having zero trust in your network infrastructure. And so then, even in that simple case, Ockham's a better solution because Ockam can keep that secure channel end-to-end through the load balancer all the way into the backend microservice. So there are certainly very well-trodden paths where Ockham's maybe not the right fit. But I feel like more and more applications, if not all modern applications, are becoming distributed. And the moment you enter that realm, Ockham's a really good toolkit to look at.
Is there any, what are the next couple of milestones going to look like for Ockam?
Great question. So we are releasing our cloud service, Ockam Orchestrator, in September for anyone to use. You can get you and your friend can have an end-to-end encrypted, mutually authenticated channel using Ockam and start communicating with each other. We're releasing a command line that goes with it to really simplify the use. But there are corresponding Rust examples to use the same. If you want more control and want to integrate Ockam directly into your application, you can use the Rust library. Or if you want something simple, you can use the command line and proxy data through the channels the command line establishes. You can run the command line as sidecars next to your application containers. So we're launching this series of things through the course of this year that we think really simplify the ability for someone to use and start integrating Ockam into their application. So that's, I think, a major thing. And then simultaneously, as we built some of these components around the command line, et cetera, we've learned a lot about further improving the user experience of our Rust library. So a lot of that is coming as part of these series of releases through the course of this year as well. And the super brand new thing is we didn't have attribute-based access control implemented until very recently. And now there is an implementation. If you want to go look at the open source code, there's an implementation of attribute-based access control in the system that it's changing rapidly as we improve it, but it's looking really, really good as an addition to the project.
Oh, that sounds exciting. Yeah, I never really thought about this. Maybe I should take a look at Ockam, and maybe I need to also implement it because I do have a heavy micro-based service with one of my projects, and it could be kind of useful because it's dealing with money, right? You always want to document where money's going and coming and everything else because that's money, right?
Yeah. So. I'm glad you brought it up. Yeah, I think that space has some really interesting use cases. I've spoken with certain teams that, do various sort of back-end financial transactions between banks, across data centers, across clouds. And in those scenarios, they're very real-time-ish, and they need really high degree of security, and they don't want intermediaries to either see the data or tamper the data. And in that situation, Ockham's a really good fit. So if you're dealing with financial data or healthcare data or, large connected infrastructure, Ockham's a really good tool set to look at.
Yeah, I mean, it would be good because right now I'm just kind of using Kubernetes to kind of talk to different services. And I can imagine in there that things can happen, right? So Ockam would help to make sure that things are flowing through. There is a telemetry piece, right, where you can kind of keep track about what's going on also, right?
Yes. So all the components of Ockam can't see the messages, but they can see the routing metadata, right? So they can see that Mrinal and Eller are talking to each other through the server. But what they can't see is what are Mrinal and Alan saying to each other, right? So the intermediaries can see the frequency of messages, etc. So that allows us to do telemetry, allows us to provide SLAs on these connections. So we can guarantee that your connection will have this much latency SLA, this much throughput SLA, etc. without becoming someone that can intercept your messages or tamper your messages, etc. So yeah, there is telemetry, and we already have users that are using Ockam within a Kubernetes environment to have mutually authenticated communication between various Kubernetes-based microservices.
Yeah, this is sounding pretty cool. It's cool to hear what stuff you're doing, and I can imagine using Rust, you get a lot of flexibility, right? Because you can basically export to wherever you want. And like you said, you get all those safety guarantees and everything else.
Absolutely. Yeah, it's been great. And it's also a lovely language to program in. It's joy.
Well, once you've been enslaved and, beaten into submission by the borrow checker and follow its rules, then yeah, it is a pleasure. So it's kind of like marriage, right? Once you start listening to your wife and all the rules she has. Sometimes you can bend the rules a little bit. Sometimes you can bend the rules, but at the same time, you can't bend too much. That's breaking, and that's just no.
Yeah, that's a lovely analogy. Yes, it is like that.
Cool. Yeah, I don't think I have any more questions. I think you answered a lot, and I think I learned more about Ockam from our session together than I learned So I hope that this podcast will be useful for other people, and Ockam will 3x their traffic this month and 10x their profits coming up.
Awesome. Yeah, I'm sure we will. And thank you for having me. I did want to mention that we are looking for Rust engineers, especially a staff level, very senior Rust person. So if you're interested in working full time on an open source library doing Rust, check out that posting. We're a very sort of open, welcoming open source community. We love new contributors. So if you want to contribute to the growing open source project, come check out Ockam on GitHub. And if you're new to Rust, that's okay too. Given we're a very multi-programming language community and project, if you're from, I don't know, C++ background and looking for a role in Rust, come check us out. If you're from Erlang Elixir background looking for a role in Rust, come check us out. We're also looking for TypeScript people. So, we're looking for people on the team and we're growing our community. So everyone's welcome.
Okay. Yeah, I did remember that you put that in the question sheet. So I almost forgot to mention about that. Awesome. Are you also hiring Elixir engineers too?
Yes, we are. Yes.
So you said TypeScript, Elixir, Rust. Is there something else I missed? Or no?
Those are the three. TypeScript, Elixir, and Rust. But we're open to someone willing to transition languages, right? So I think people with C++ backgrounds can transition into Rust easily. People with Erlang background can transition into Elixir. Maybe people with Scala background can transition to each of these languages. So we're open to that kind of I've mostly done work in other languages, but I'm open to learning Rust and Elixir.
Yeah, actually, I did have one last question I wanted to ask earlier. Now you brought it up again. You do have an Erlang background versus Elixir background. Why is it not just use straight Erlang? Because, what you can do in Elixir, you can pretty much do with Erlang, right? Is it because the tooling is just so much better?
So tooling, yes, but I was pretty comfortable in Erlang before I was exposed to all the niceties of Elixir. So I personally would be just fine in Erlang land. But what I realized several years ago was that it is much easier to teach people Elixir versus Erlang. And the number of people who know Elixir in the world is growing way more rapidly than people who know Erlang. And so the fantastic work that community has done around good documentation, ease of APIs, simplifying some of the very terse Erlang ideas into very simple APIs is paying off, right? And so it shows in the community growth around Elixir. So the reason to choose Elixir to build Ockam was simply that the likelihood that we will be able to find people who can write Elixir is much higher than Erlang.
Yeah, I guess that's also true too. It is a much easier language, unless of course you like that kind of interesting language. If you remember writing Erlang, it's definitely takes some time to get used to with all the commas and periods and yeah.
Yeah, honestly, my personal opinion is on the beam, Elixir and Gleam are much better languages than Erlang in terms of style, simplicity, abstractions, documentation, tooling, etc. Or Gleam's really new, so the tooling isn't quite there yet. But Elixir definitely, the tooling's really nice. But the key thing to adopting Erlang or the Beam is learning the basics, the actor primitives, the OTP framework. And those are the same across these languages, right? They're the same word that you get any of the Beam languages. So I think Elixir is best of both worlds. You get the power of the core Erlang OTP primitives, and you get the simplicity and ease of a more modern language than Erlang.
Yeah, definitely true. Also, a little bit less use Gen Server over doing all the boilerplate for Gen Server by hand, I think is another big one.
Exactly, yeah.
Cool. Well, again, thank you for your time. Again, I apologize about being so late, but I'm happy you could stick around.
Oh, yeah, no problem at all. It was absolutely a pleasure. Thank you for listening to me, and thank you for having me.